All right, so our objective, the FYI, the computer's lagging, so hopefully it sticks with us today. We're going to evaluate and graph the absolute value function. So we're going to solve for absolute value equations and solve absolute value inequalities. Okay, absolute value function. Do you remember this guy? Yes, the V shape. Okay, main attributes of the absolute value. It makes a V shape. The domain is all real numbers. The range is from 0 to infinity. Its x and y intercept are at the origin. What makes absolute value special is that it is what we call a piecewise function, essentially made up of two vertical lines, one with a negative slope. So this side has a negative slope and this side has a positive slope. I wrote negative, slope, slope. All right, so back to what we're talking about, absolute value functions. Other than that, those are the main properties of it. So left side, negative slope, right side, positive slope. Now, because of this, what that means is that when you are solving absolute value problems, you're going to have two possible situations, right? But we're going to dive in that a little deeper. But right now, we're going to start with analyzing the function. How many of you remember our transformation rules? Like what makes something go left, right, up, down, all that good stuff? Do you remember those? So do you remember seeing f of x equals a absolute value of x minus h plus k? Do you remember that? Oh, it's going to come at some point. Yes, we did. It is what it is. I remember the internet's going really slow. And so I have fully written out what it needs to say. It's just taking its time to get on the screen. All right. Does that look familiar?
Oh, yes, it does.
It looks a little bit. So remember your A, your H, and your K have different roles, right? Your A is your what? Anyone remember? Anyone remember what A is? Yeah. How does A affect your graph? We're not there yet. A is your vertical stretch or compression. Does that ring any bell? Yes, your X is a liar. Okay. Your H tells you whether you're going left or right. And your K tells you whether you're going up or down. Now, is that ringing bells now? Okay. Together, your H and your K are your vertex. So when I look at this, it's x minus 2. That means that my K value equals -2. So that tells me that I went down 2. So if you were unsure, if we were to graph this, you would see that that's what that would mean as far as, hold on. Sorry. I don't know what else values are there.
What's H stand for?
It's just a variable for horizontal shift. So if I have absolute value, to put absolute value in, I go to math, number, abs, and I put in absolute value of x minus 2. That causes it to shift down. If I did absolute value, so math, abs, and I put in x minus 2 inside of the absolute value, what do you think that's going to do? Now what variable am I looking at? That's my h, right? If it's inside the parentheses, is now my h. And what do we say about x's? They lie. So even though it's a minus h, It looks like you're going to be going to the left, but you're actually going to the right. And that's why I would shift to the right. Okay. So that's what we have here. So depending on how you're analyzing this, so if I was just finding the absolute value of the x, that's what it would look like. If I was finding the absolute value of, there's supposed to be another one, f of x equals the absolute value of x minus 2. So that one, I now have my h, and h equals 2, which means it's going to go right to. Everything is based off your parent function. So without any additives on, we're at the origin. Once we add additives, we start shifting around. Okay, now let's look at this one. It says, if we have 1 minus 2x, and it wants us to find the absolute value of 1 minus 2x. So this time, this one is f of x equals the absolute value of 1 minus 2x. So this is the different part from being in Algebra 2, is that in Algebra 2, we didn't really use our b value, okay? Which is the number with x. Before you can analyze this, you actually have to rearrange and factor out that value and go from there. So when I do this, what it actually is representing is -2. And we have x minus 1/2. And the reason being is because you're dividing out -2 so that x is by itself. Because if you go back to the form of f of x equals a absolute value, there's this b term that could be here, which is our new guy here, minus our h plus k. But this is a special h. As long as there's a b, that's not our real h value. It's in disguise. So you have to factor out the b in order to find your actual h. So the actual h here is at -1/2. And we're going to analyze and see what that graph does. So I'm going to clear my calculator. Anyone remembers how to clear? 712. Second plus 712. So when I put this into the calculator, I'm putting in the absolute value of 1 minus, well, let me put in the original absolute value, math. So I'm going to put in the parent function, which is just absolute value of x. And I'm going to put in this transformation of the function. I'm going to do it in 2 parts. So first I'm going to just put it in with the x minus 2. So absolute value. I'm in x minus 1/2, x minus 1/2. I'm going to hit graph. So here's my parent function. Notice that the 1/2 just slightly shifted me to the right, right? Now that 2, I'm going to add that 2. I'm going to insert 2, insert that's not a parenthesis. Parenthesis. And I need another parenthesis. I didn't want to retype it all together. I was being lazy. So I use the insert button. Insert button can be really tricky, but I inserted the 2. So we already know that the 1/2 caused us to shift to the right, correct? Now, what do you notice the 2 did? What did the 2 do? It made it stretch, right? Do we see that? So the 2 right here, the way we actually look at it, the 2 is called a horizontal compression, okay? It looks like a vertical stretch, but it's called a horizontal compression. Imagine you playing an accordion and you went, you applied more pressure. And when you apply more pressure, what does it do to the accordion? It condenses it, right? So it was a compression, but it was horizontally instead of vertically, okay? So we did a horizontal compression. Okay, so when there's a number with the x that you have to factor out, this is our horizontal compression or stretch. That's the separation from between the two classes. One of the separations is that we really don't deal with it in Algebra 2. And now if I ask you, where's the vertex? Your vertex is at 1/2, 0. But it was a horizontal compression. All right, now the next thing we got to make a change to is what?
I got one question.
Yes.
So the vertex, how does the negative become not a negative?
So with transformations, it's already part of the formula of a minus. And so that means that this is already a positive number. And the only way this is going to become a positive is if this number is a negative. That's why we remember our x is a liar. So even though we think it's a negative 1/2, it's actually just x minus a positive 1/2.
Wasn't it already a negative on this side? So it has to be a negative to make it a positive?
No, that's why you have to factor out that -2 first. So notice how before we did anything, we rewrote it in its proper format. So we factored out the -2.
Oh, okay. Okay.
Yeah, because you're, yeah, so this is positive 1/2, it would be negative 1/2 at the vertex. Okay, now we're going to analyze what is this negative going to do? Do we remember what the negative does on the outside of the absolute value?
That's a good thing.
It makes it reflect over the x-axis when it's on the outside of the absolute value.
Oh, wow.
What do you think it's going to do on the inside of the absolute value? So the outside makes it reflects over the x. What do you think the inside is going to make it do?
Over the Y?
The opposite, exactly. So I'm going to insert a negative, and we're going to analyze that little piece. So now I'm going to go back to absolute. I'm going to come right here, and I'm going to hit insert, and now I'm going to put in a negative. So now I have the -2, and we're going to analyze what happens when I graph that. So there's my parent function. And there is my graph. It doesn't look like much took place, but it did. Let me zoom in. Parent function. And then the reflect. What happens is it literally just reflects over. As far as the value goes, slight change. So let's look at it from the table. What happened? So we're gonna math. I'm gonna look at it from the table perspective, and we're just gonna put in 2x minus 1/2, close parentheses, and we're gonna go look at the table. So we're gonna compare y2 to y3. So what you see here, notice that in this situation, we have, did it make a big difference? Did the values change? Do y'all see any difference? And this one is the absolute value of negative, and this is the absolute value of positive. Why does it not change in the sense of an absolute value? What do absolute values do? What do they do? It eliminates the negative, right? Absolute value eliminates the negative because absolute value is the distance, and is distance ever negative? No, if you're walking backwards, I'm not going to say, oh, you went -2 miles. No, you're just a fool who walked backwards for 2 miles. Okay. So therefore, when the negative's on the inside, it has no effect. It only affects it if the negative's on the outside, because that's after you're away from the absolute value. Okay. So notice how this negative on the inside had no effect. I think someone else covered it. Okay. So I needed a page of summary. So summarizing our function. So we have f of x equals a absolute value of B x minus H plus K. Our A is our vertical stretch, compression, and x-axis reflection. This is knowledge you should have coming into the class. Okay. Our B is our horizontal stretch and compression,
What's that last word? So it's so-
reflection, compression. Our H tells us whether we went left or right. And we got to remember that it's a lie. X is a liar. X is a liar. And then K is our up or down. So those are the, without graphing, you can make an assumption of what's taking place. Okay. Key thing to remember is that it's a vertical stretch if A is greater than 1. It's a vertical compression if A is between 0 and 1. And it's a reflection if A is negative. Okay. Horizontal is a little different. It's a horizontal stretch if B is between 0 and 1. And it's a horizontal compression if B is greater than 1. And then left or right is what it is. Left is going to look like it looks like a plus. Right, it looks like a negative. Up is plus, down is negative. A is negative.